Hi children, welcome to another lesson in mathematics. We are still on numbers and number operations. So by the end of today's lesson, children, you should be able to show understanding of the property of commutativity. Yes, the property of commutativity. Now let us look at our keywords. We have one keyword and it is commutativity. So this relates to exchange, the exchange of something. Commutative. Yes, so this means that the same result is given whenever or whatever order the values are in. So in whatever order the values are, there should be what? The same answer. So assuming you have two different sets of numbers, when you change or you exchange the numbers, they should end up with the same results. That is the property of commutativity. That is getting the same results no matter the positions of two numbers. Good. So in our previous lesson, we looked at the strategies in addition and subtraction. We looked at 4 strategies. So our first strategy was changing addition sentence to subtraction sentence and changing subtraction sentences to addition sentences. I hope you remember that. And then we spoke about decomposing. And then we did friendly jumps as well. Friendly jumps in subtraction. And then we looked at splitting of numbers. So today we are moving on to a different aspect of addition and multiplication. So today we'll do mostly addition and a little of multiplication. Okay, so let us look at the property of the commutativity. So we have an example as a plus b. What will be the answer? So a plus b should be the same as b plus a. So the answer you get for a plus b should be the same answer you get for b plus a. And then we have a times b. So a times b can be written as b times a. They should both have the same answer. Now let us put numbers and then try to solve them and see if we'll get the same number for the exchange. Good. So we have this addition sentence on the board. Now let us interchange their positions, the positions of the numbers, and then solve them to know if we have the same answer for both. So we are changing these numbers, their positions. So we will put the second number first. So we have 453 plus the first number, so 236. So it's just an exchange of their positions. Let us add both numbers and see. So we have 236 plus 453. So 6 plus 3, you have 6. You're adding 3 to it. So 6, 7, 8, 9. So we have 9 here. 3 plus 5, we have 3. We are adding 5 to it. So 4, 5, 6, 7, 8. Good. Now 2 plus 4, 2, 3, 4, 5, and 6. So we have 689 for the first addition sentence. Now let us look at the second addition sentence. We have 453 plus 236. 3 plus 6, you have 3, you are adding 6 to it. So 3 4, 5, 6, 7, 8, 9. So we have 9. 5 plus 3. We have 5. Let us add 3 to it. So 5, 6, 7, 8. 4 plus 2. So 4, 5, 6. So we have 689. So we realize that changing the positions of the numbers didn't affect their results or the final answer. We have both numbers having the same answer. So this is what we call commutative. Exchange of numbers shouldn't affect their answer. When you exchange numbers, it should give you what? The same result. So commutativity, or the property of commutativity, goes with addition and multiplication. So let us look at the multiplication aspect of commutativity. Good. We are looking at another sentence. That's the multiplication sentence. So let us have 10 times 5. So 10 times 5, we are changing the positions of the numbers, not the sign, the numbers. So in this case, the 5 will come first. So we have 5 times the 10. Good. So we are just changing the positions of the numbers. Now let us multiply the first number to know if we can get the same result as the second number. So we have 10 times 1. What do we have? 10. So 10 times 2 will be what? 20. 10 times 3, we have 40. 10 times 4. Sorry, 10 times 3, we have 30. 10 times 4, we have 40. 10 times 5 is what? 50. So 10 times 5, we have 50. Good. Now let us look at the 5 times table. So 5 times 1, we have 5. 5 times 2, 10. 5 times 3, we have 15. 5 times 4, 20. 5 times 5, we have 25. 5 times 6, 30. 5 times 7, 35. 5 times 8, we have 40. 5 times 9, 45. And then 5 times 10, we have 50. So 5 times 10 will give us what? 50. Changing their positions didn't affect their answer. So this is what? Commutative, the exchange of what? Numbers, resulting in the same answer. Let us look at another example of the multiplication sentence. Now let us look at 3 times 4. 3 times 4 can be written as 4 times 3. Now let us look at the 3 times table. So 3 times 1, we have 3. 3 times 2, 6. 3 times 3, we have 9. 3 times 4, we have 12. So this becomes 12. Now let us look at the 4 times table. 4 times 1, we have 4. 4 times 2, 8. 4 times 3, 12. So 4 times 3 will give us 12. So we have the same results. So children, this is what we call the property of commutativity, which means that whatever order the number is in, they should both have the same answer. So changing positions of two different numbers should result in the same number. Good. So children, this is what we have learned today. When we come on Zoom, there will be more examples to solve. But for now, try your hands on more examples. In addition and multiplication, write two numbers, change their positions, and then solve them and check if you will get the same answer. If you don't get the same answer, then it means there's something wrong, because the property of commutativity tells us that when we change the positions of the numbers, we need to get the same results. Good. I'll see you all next time for another lesson in mathematics. Till then, be good children. Bye bye.